All right, back into it. We're going to jump into the intersection last shape, which should be pretty familiar to people if you can just swap your idea from Boolean in Rhino to solid. Because they're just choosing Grasshopper to use solid instead of Boolean, and I think that's because of the logic of the Boolean toggle and not wanting to mistake. Uh, Consider you're thinking of a solid instead of what's termed a Boolean difference or intersection or union in Rhino. Um, that may make sense to some, it makes sense to me. So, intersect shape. Be sure to deactivate the solver before changing data. So, hit your scroll key and deactivate solver before you start sliding things around in here because um, you can also do it with the space bar or pressing control wheel to access. Um, Now you're dealing with solids, so things start to slow down. And as you take a look in here, you'll see 53 milliseconds on a polar array. Probably some big time limits here, 1.117, 368, 86 milliseconds for this difference to occur. And if you don't see those profilers, you want to go into here, System Preferences, go down to Widgets, and make sure you are selecting, at least I thought that was it. The profiler, you're going to want to make sure that's on Show Profiler Widget. It's a bigger icon system than the information system that I'm used to. Okay, so be advised to bake into Rhino environment and then do the Boolean unions, which would be the solid unions. And that's just something I end up doing. I try not to do a lot of any scripts that get over, indicate that their size is getting over, whatever, 50 milliseconds or whatever, 10 milliseconds. I kind of scrap it and leave it later. So let's just turn this off and see what we have. Well, once again, I'm dealing with a range and a jitter and some points. I'm grabbing myself a sphere. I'm evaluating surface at just a ton of points and point normals to produce, this data. Maybe I should take this off, like I always advise. And then rectangles are being created at all of those. Now, why would I do that? Just to complicate it with a bunch more surfaces and find a boundary volume. That's like where all those rectangles intersect, and I make this kind of gemstone. It's just a wonderful way to randomly facet something. So if I went in here, it's got to be a seed around here somewhere. Well, I have to kind of seed it through my point system, my jitters. So let's throw a jitter in here, 1.00, which allows me from 0 to 1 to jitter this. And that's one way to change it. Or I could go so far. What did I say about locking your solver before you do things like that? Because I have to wait for the time to run. And here we go. I'm going to have a sip of coffee. And wait for that to kick in. And the other thing would be lock my solver and put on a seed. And then I can slide through my seed and change that as well. But instead of plugging that in, let's see what happened to my outer shape. Oh my gosh, did I ever blow that apart by the jitter. And I just, sorry, we were looking into that solid that's created and how it changes. And then I just did a 3D rotation of all those geometries by the centroids. And because there's a list of this coming in, what do I have? I have 11 points of where it's rotating. I'm able to do a polar array and produce this amazing looking crystal. So let me just bake that. Let's put it all into one. Let's leave Grasshopper, grab this thing, slide my face over, and do a little surface zebra. Give it something, ruby red. Not so red, pinkish. It's going to be kind of ugly. There we go, and we'll throw it into a rendering and see what we have here. So you have this kind of crystallized form. And once again, do your zoom, select. Now you can actually roll that around and see what you've ended up creating. Kind of a nice little form. Powerful, dealing with, but slow. 16 seconds for this boundary volume to change. So that's why you don't maybe want to get into slowing your scripts down. This is the tendency that people get 12 nodes up and running, and they're like, Grasshopper stinks because it just doesn't do enough complicated things. Well, that's because you're trying to use your intersect shapes, very heavy, what are called heavy components to do this. So I'm going to group that, and take that to a color that I actually like, give you your warnings on it, and I'll probably go so far as to disable. Keep an eye on your profiler widget. Consider baking in a Rhino environment before performing these operations: solid difference, solid intersection, solid union, which are referred to the Boolean difference, Boolean intersection, Boolean union. Split and trim with breadth is probably a little quicker. Let's grab that solid again. Let's jump onto all those evaluated surfaces. Let's put those planes on there. Let's take a cone and say, okay, from this cone, where do I get all these? I got to cap it so I'm actually dealing with a solid. And then that geometry has been rotated and jittered and blasted. I believe I can jump in there. I didn't even actually put a jitter on that. But that Boolean, you can see, is 5 seconds to change it. Basically takes all of those cones at where it kind of crosses over into this and produces the curves, and then do-si-doing around with solid trim. Choosing a list index lets me choose the outer side pieces, choose the inner, and then select. What did I end up selecting? The same one again. I selected this one of the same objects. So just 2 ways to get at the same thing: one through a split rep multiple, and one through a trim solid. So play around with these, and then once again, if you're going to offset this surface, take a look at it. It's an open rep. Let's take that to a bake, for instance, and I would recommend this. I guess we can join it. Let's leave Grasshopper, and probably the best way will be offset surface, which I think a lot of people are used to doing in Rhino. Let's just hit enter and see if that works. It might have a few technical problems, but it didn't, and it offset beautifully. And there you go. Nice offset surface that you didn't have to push through Grasshopper and produce your own kind of space station. Since we're looking into future cities and sustainability, I'm not sure if you can think of the ideas of optimizing and making these relative to the size or scale or weight. Those are things that I want your mind kind of considering. So I'm going to erase that one. It seemed to work, but I didn't take all the scripting through Grasshopper. As soon as I get into these kind of unions and differences and intersections, I slow things down. So let's just let's take that one and put that one off as well. Let's go into the next one. A very simple algorithm. Grab yourself and the simpler you make it, the 2D you make it. Let's just grab some grids. There's a whole bunch of different grids, and I'm just doing a region difference between it, a region union between it, and a region intersection between them, just to end up with these geometries. And it's on a 2D surface, so it's fine, but play around with that. Change your x extend, y extend, plug in some different grids. Very simple algorithm, but consider the geometries that can be created. Consider what is going on behind the scenes in the mesh plugins, and this should look very familiar when you see this, because this is the Daniel Christev mesh from points surface that I continue to use, because I'm not interested in meshes, but I'm definitely interested in Daniel Christev's mesh generation, which gives me some pretty awesome control as I slide this throughout. Let's see what happens. This one probably has an influence on it. Change. Oh, something's happening. These two are dead. Why are they dead? And why is that one working? Maybe because I'm only looking at 1 point now. All those are dead. What is going on with my surface creation? Let me see. Points. Played around with it a little too much and offset it. Let me see if I can get that one up and running again. What is going on with my surface? Here's my surface. Here is my evaluate point nodes. Let me take this off. You should, when you start doing things like this, you'll find you are debugging. You're just debugging in a visual kind of way. My point should be here, an empty point parameter. So my geometry is here, which is a scaled geometry. Do I have a geometry? Take a look. One untrimmed surface. It flows into here, but my points are not coming out, probably because they're not touching in some capacity. Let me have a look to see if I can solve my problem. There's a subtlety. I had locked my solver, and everything I touched was just fudging worse and worse and worse. So let's jump back into that surface edit, and it was updating, but because I had locked my solver, telling you to it was updating very slowly. I also turned off everything else that was kind of running kind of slow. So if you take off your solver, try not to make the habit of leaving it off, or you'll start to see things fudge out. So I produced this mesh from, and you could just produce a mesh any way you want. You don't have to be crazy like myself and Daniel Christoph and want a complex script like this, but I just like the control over it, and I like to use it as an example. So what I've done is I have a little relay. That's something I haven't used. It's just to double click on that. Your relay's over here, but if you click on it, you can haul everything up. But just see I didn't grab everyone. So let's just go back to this. And there's my relay that can drag around all the wires. You literally just double click on a wire and then double click to take it off. And it's like plugging in a relay for electronics. So Meshbox was something I had here, but I decided to use a mesh sphere and put it on as this was the surface. These are the deconstruct mesh vertices. I put on spheres so they'd run faster than a regular surface sphere, rep sphere. And I can do a mesh difference, a mesh intersection, a mesh union, and a mesh split. And you might want to get into this if you're thinking fabrication and you want to have a complexity, but really nice control over these four shapes. So this one, what I would suggest is going into set, grabbing yourself a list item. You could merge all this. This is good practice. Merge everything so you can see the order of what's coming in. 3, 4, 5. Obviously, number 2 actually has quite a few items on it, but because 1, 2, 3, 4, 5 results, I'm going to have an index of 0 to 4 as an integer value, and I can take a look at each of those units. So 1, 2, 3, 4, 5. And I'm seeing everything because I have not flattened my list. So if I flatten my list, I'm able to run through all of these points right like that. Now the problem is this list flattened produced way too many meshes, and it's because of this complexity here and this list here. So that's not actually working. I was hoping it would. I'll have to think of it a little different. You could also do a gate to allow through these items. These are all the surfaces that are cut out. This is the surface with the cutouts. This is the one with the spheres. This is the one with the spheres. Three-dimensional, obviously a mesh intersection, and that's the mesh difference, which removes some pretty nice subtleties as to what you could end up doing in controlling a more complex geometry. I think I'll take that one over the bake. I've got mosquitoes in here because it's that time of morning now after a wonderful morning of crickets, which have started to get a little quiet. There's a few left. I believe I've taken it in the bake, and I'm going to take it over to render, and we will leave our grasshopper, select this one, and do our analyze surface environment map, and pretty sweet that you've gained a little bit of control in fabricating something like this. Not a bad unit to consider what that would look like on the surface of something. And that's just coming from that very simple mesh that has full control over what you do. All right, a lot of information, a lot to play with. I think many of you will get tied into this script and enjoy it and do an awful lot with it. Contact me directly if you want to. I'm actually going to try and get a Discord channel going on Reparameterize, the field questions and technically answer, because it will be good for my students at my school, but also working collaboratively overseas and seeing how far we can push this and see what types of beautiful geometries and surfaces we can create. Thanks again for watching. We're going to move on to transformations, which should look familiar as well, but there should be some affine and arrays in there, and Euclideans and morphs you don't know anything about, and certainly some utilities. Thanks for watching. It is Sunday, September 12th, 2021.